Highlights for fluid mechanics multiple choice question preparation for exit exam. So let's take about the characteristics of fluid. First, fluids don't have a set of shapes of their own. They kind of just take a shape of whatever the container they are in. Like if you pour water into a glass, it fills up the shape of the glass, right? Next, even a little bit of pushing or steering can make a fluid change its shape. Apply some force and it starts moving and deforming. This continues as long as the force is there. A fluid is a substance that deforms continuously under the application of a shear stress, no matter how small the tangential or the shear stress force is applied. Let me explain the concept of density, specific weight, and specific gravity. First, density. Density is a measure of how much the stuff or the mass is packed into a certain amount of space or volume. Imagine two boxes with the same size. If one box is filled with a feather and other with a rock, the box with rock is denser because it is heavier for the same size. The formula of the density is density equal to mass divided by volume. Next, specific weight. Specific weight tells us how heavy a substance is for a given volume. It's like the weight of a certain amount of material in a specific space. For example, a big balloon filled with helium is lighter per cubic meter than the air balloon filled with air. The formula of specific weight equal to weight divided by volume. We can calculate specific weight using density and gravity also. Next, specific gravity. Specific gravity compare how dense a liquid is to the water or air. The formula of the specific gravity equal to density of a substance, gas or liquid, divided by density of water or air. These concepts are important in science and engineering to understand and describe the different material and fluid. They help us figure out how things behave and interact in the world around us. An ideal fluid is a theoretical concept used in fluid mechanics. It's characterized by the following property. Ideal fluid doesn't have viscosity. This means that an ideal fluid has no internal friction between the particles. It flows without any resistance. An ideal fluid exhibits no corrosive force at its surface, and an ideal fluid sized by incompressible. The density of remains constant regardless of change in pressure. On the other hand, real fluid is a practical concept representing most fluids found in nature. Real fluids have the following property. Viscosity. Real fluids exhibit viscosity which is the internal resistance to flow. Viscosity causes fluid layers to slide past each other and affects the flow behavior. Surface tension. Real fluids possess surface tension. The corrosive force has their surface that tend to minimize surface area. Compressibility. Viscosity is a key property of fluids that determines their resistance to shearing stress. It represents how fluid layers resist flowing past each other when subject to an applied force. The viscosity of the fluid arises from two main factors. One, cohesion, and second, molecular momentum exchange. Cohesion refers to the molecular attraction between the fluid particles, which creates resistance to flow. Fluid layer exchange momentum through molecular interaction contribute to internal friction and viscosity. Loss of viscosity, also known as loss of friction, fluid friction, describe the relation between shear stress and the rate of shear strain within the fluid. According to the Newton's law of viscosity, the shear stress experienced by a fluid layer is directly proportional to the rate of shear strain. Kinematic viscosity is a fundamental property of fluid defined as the ratio between dynamic viscosity and density of the fluid. It quantifies a fluid resistance to flow relative to its density, and it denoted by the formula nu equal to dynamic viscosity divided by density. The effect of temperature on viscosity. Temperature has a significant impact on the viscosity of the fluid. Viscosity of liquid decreases with an increase in temperature. This is because higher temperature disrupts the molecule cohesion regarding internal friction and fluid viscosity. In contrast, viscosity of gases increases with higher temperature. This occurs because of gas molecule gain kinetic energy at higher temperature, increase their collision and resistance to flow. Effect of pressure on viscosity. Pressure has a very little effect on viscosity, but if pressure increase, intermolecular gap decrease, then cohesion increase, so the viscosity would be increased. Surface tension. Surface tension is due to a cohesion between particles at surface. Capillarity action is due to both cohesion and adhesion intermolecular forces. Thank you for your watching.